Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So we are in episode 3 of the design and construction of this universal modular enclosure, and I'm building this one for a fiber laser, but you could build one of these for all sorts of machines. 3D printers, lasers, probably the two most popular things, but I've seen so many great suggestions down in the comments of the previous week's videos, and if you missed week 1 and week 2, I'll link those down in the description of this video so you can go watch those first if you want. But this is basically an enclosure that is designed around 3D printed edges and 3D printed corners. And then the rest of this is constructed from just cheap coroplast. This is like a corrugated material that is used often for signs. And you can buy this in all sorts of colors and it is cheap. Before we get started this week, I did want to take just 1 second and thank you guys. Not only for all of your comments and suggestions on this design and build series, but for all of your likes and subscribes during the time you've been here watching the channel. This channel just recently crossed 25,000 subscribers, and that certainly would not be possible without the support of everyone watching these videos. You know, you guys sharing them with your friends, hitting the like button, subscribing to the channel. Thank you so much for doing that. It really encourages me to keep going on stuff like this. These projects do take quite a bit of time, and I was doing stuff like this anyway before I started the channel, but the pace has definitely picked up, and just keeping stuff moving forward at a pace fast enough to actually put out content every week. So again, thanks so much, guys. So the main thing I want to accomplish this week is finishing the design for the door and getting it installed and tested and hopefully all working. Now, I had some of the design for this done. If you guys saw last week's video, you saw sort of a preview of what the door was going to look like, but the design was not finished. We've still got quite a bit of work to do on that. But before we do that, we've got a couple other things that we have got to fix up on here. If you remember when we left off in last week's video, let me just get this set down here. Actually, the front here is a perfect place to see the issue. Because we left the bottom of this open, and that was my intent. I wanted to leave the bottom of this open, but I hadn't considered the fact that with nothing in the bottom, there's really no strength in these pieces because the corrugation on the sides runs vertical, and these pieces just fit together, so we have really no strength there, no strength here or on this side either. Now, I think there's a number of ways we could fix this. We could probably just cut some strips of this and put them in there and tighten it up, and that would probably work okay. But I think a solid piece of material in there is going to be even better. So let me go up and see if I can just draw up a piece that'll fit in here that already has the screw holes in it to connect these pieces together rigidly. And we should be able to just use the same piece here, 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 and here. So let me go draw that, get some printed out, I'll bring you back. All right, drew that up and printed out 4 of these, and the design of these is super simple. It's 4mm thick, just the same as the coroplast material that make up the sides of this enclosure. And one end is beveled. The end that's beveled goes into the slot. The inside of that slot's actually curved. I beveled this because it is much easier to have this face flat on the bed and print a 45-degree bevel there than trying to print a curve. If you've ever tried to print a curved surface up off the bed, you end up with kind of a nasty overhang and it just doesn't print clean. The bevel sort of gives us the same effect of keying into that rounded section, indicates which way it goes in since these screw holes are not centered in the piece, and should make this guy just easier to insert. So let me get the camera kind of moved around and see if I can get the 4 of these installed and get that stiffened up. All right, these are going to attach with the exact same screws that we are using to attach the coroplast into these side pieces. And you might have noticed I didn't actually put those screws in yet. I said last week I was going to do that off camera. I decided to wait because there's really no rush to put the screws in. Everything's staying in place. I think I want to wait till this is 100% done, and then I know for sure I don't have to pull anything back apart, and then we'll put the screws in as a last step. But I do want to get these in because we got to solve the problem of this flexing. All right, Yeah, that has completely stiffened that up. It has no flex at all in it. So I'm going to do the same thing for the other 3 sides, and we'll move on to the door. This is just a punch I'm using to make sure that the holes are lined up. You really just need to make sure the first 2 are lined up. Your other 2 then are pretty much guaranteed to be in alignment. If you don't have a punch set like this, you can just use a nail. The idea is you just want to make sure that you can reach this guy in. And I'm just checking the depth to make sure that I am going through this piece, and that screw is going to not try and enlarge that hole or miss the other side. All right, that is all 4 of those in, and I think we can cross that one off the list. These are nice and rigid now. I can't move that at all. And I'll put a link down in the description again to this guy, this little high torque electric screwdriver that is out of Japan. Not a sponsor, this was a gift from a friend, but it is like the perfect amount of torque for projects like this. All right, well, with those bottom sections stiffened up, I think it's time to
draw a door.
Draw a door.
Yeah, we're not going to get off quite that easy, but yeah, let me go up to my desk and open up CAD and start trying to figure out how to draw the rest of this door. I have the overall shape down. I just need to figure out how the actual acrylic is going to get retained in the frame, and I need to design the hinges on this side. I have done a door on another project before, and there is actually quite a bit to consider for having that door swing within the frame and having clearance for everything. Particularly since I want it to be fairly tight. I don't want light escaping around those edges, particularly up here in this part of the enclosure. So, all right, I'm gonna get to drawing and I will bring you guys back. All right, and here is the design that I came up with for the door and the door frame. And again, this is gonna fit through the front piece of coroplast in the enclosure. So it's actually gonna mount basically to the coroplast sheet itself. And first thing you'll probably notice is the outer part of this is in 2 different pieces. So if I hide the acrylic and the bezel for the acrylic for now, you can see this is the outer part of the frame, and this is going to print in 2 different pieces, and that's because of just the sheer size of it. It's not super long in this direction. Once we cut it in half, it's 242.5, so that would fit on the bed of one of my Bamboo Lab machines, or certainly the Cheaty Plus 4, but in this direction, it's 383. So the only machine that's just going to fit in is the Neptune 4 Max. And this is going to need supports on the bottom as well. So this is going to take a little while to print, and I'm really just kind of crossing my fingers we get decent quality because, yeah, that machine's not the best. In this direction, this is 485 millimeters. So we'll be able to print the, like sort of the bezel for the door on the Neptune 4 Max in 1 piece. But yeah, this outer part is just going to have to be in 2 pieces even for that machine. It also means we need to figure out how to join these together. I came up with this idea of just having some sort of dovetail bow ties in here. And what this should allow us to do is tweak the size of the sort of, double dovetail section, the insert piece, till we get a nice tight fit and it draws this together. So what I'm trying to avoid is printing these outer parts more than 1 time. If the fit of that piece that presses into here isn't great, we can always just, change the size a little bit or adjust the design so that it is a nice tight fit in there and draws these together. Now, I think we're going to get a good amount of strength drawing those together there. However, let me just hide one of these halves. I'm worried that we're going to have a fair amount of flexibility by the time we get over here to sort of this part of the frame that the door and the bezel close against. And this hole here is sized for a piece of just plain old filament. Figuring we can just cut ourselves two short pieces of filament, shove them in each end, and that should, in shear strength, give us a fair amount of rigidity there where those 2 pieces meet. Again, the filament's not going to be super strong, but once this face is right against the face of the opposing part, we're looking at just the shear strength of that tiny little bit of filament. It should be strong enough, I think, to keep that nice and snug. So let me go and unhide everything. Just so we can kind of take a look at the rest of this. The other piece that I needed to solve here is how this is going to swing inside the frame. And the tricky part of that is, how do you get the door in place with the pins long enough for it to swing on, and also have it removable for the future? And I came up with possibly an overcomplicated design, but I think it is going to work well. So let me just explode this. We'll turn on our hidden geometry, because what I want to do is whack a face here. So we have two bores here, and it's not by mistake that they don't perfectly line up. What I'm thinking is, this extends out of the bottom of the frame. So you won't really see this hole. This is on the bottom. And that is going to have a solid dowel pin in it, and then a grub screw behind it that will push that dowel pin in. And that dowel pin will go into this overlapping section and push on another dowel pin that actually goes into the hole in the door. So the idea being, we put our first dowel pin in, we put our grub screw in, and we slide our other dowel pin in on this side so that the end of the dowel pin is flush with this face. We put the same dowel pin up in the upper end of the door and just press that into place, and then set the door down in, and then tighten our grub screw, and that should push the dowel pin out of this bore and into the door. And we just keep tightening that grub screw until it's pressed all the way into place. And that way, should we need to get this apart in the future, we can back out that grub screw, and those two dowel pins should slide back in, and we can get the door back out. Now, the dowel pin might be a little snug in that hole. It might be a little tricky to get the dowel pin to come out of the door and back into this bore, but I'm sure we can figure that out should we actually ever need to get this door out. And this will definitely work for assembling it. We'll be able to mount the entire frame into the overall enclosure and then put the door in afterwards, since this hole will be accessible from the outside. And I think that is really the majority of the complexity here. Let's see, let me just hide everything for the frame. If we look at just the bezel and the door, the door itself, which is the bezel and the piece of acrylic. And the majority of the strength here is actually going to come from the piece of acrylic. That's what's going to hold this square. I designed some tabs into the corners and into the sides so that we should be able to flex the frame and the piece of acrylic and basically just have it sort of end up captured inside of there. If it's not real tight, maybe we can use some glue or some caulk just to keep it in place. But if I hide just a piece of acrylic, you can get kind of a better idea of how that is going to fit underneath these sort of little tabs, and underneath these tabs in the corners. And we've got a nice pull handle to open this guy up and to close it. This is going to be magnetically latching. You see there's two holes here. We'll press magnets into those, neodymium magnets, and then there are matching magnet holes on the outer frame of the door. I'll bring that geometry back. And see if we hide this guy now. Yeah, you can see a matching hole here. So a neodymium magnet will be pressed into here and then down in the bottom section as well. And those magnets will meet up and should keep this door latched and hold onto it strong enough, but not so strong that we can't grab a hold of that handle and open it fairly easy. Had to knock out a portion of the geometry down here to allow the door to swing. That's what I was talking about, the big complexity with doing doors like this, especially if you don't want to take up a lot of space. You're trying to keep things as slim as possible. I had to skinny that up a bit and adjust where the door was swinging, and also adjust a little bit of the edge of the door so that there's enough room for that door to actually swing in this space. Because when it swings, those straight sections that normally wouldn't protrude past this face here, this face, are going to swing down into this geometry. So with that little bit of relief, we should have enough room for that door to swing. And it will open more than 90 degrees, probably maybe an extra 15, 20 degrees, so that we have a nice good view into the chamber. So, all right, this is going to take a while to print, so I'm going to get these started, and I'll bring you back when I got some pieces. All right, I already tested the press fit of the magnets into the door frame here in case I needed to reprint that. They fit fine, so we're good with those sizes. What I want to do first is see if these join together the way that I had hoped. Oh, you know what? We should probably put the, so we have these holes in here for filament. Not sure how far that should go in. It's a little looser on that side. All right, let's try one on this side. Yeah, see, that is snug. Let's see if we can get those to seat. Okay, that's one side. Nah, that wasn't so bad. All right, now these should lock this in place. Yeah, they're too loose. Yeah. All right, I think we're gonna have to print bigger ones of these. Yeah, same thing on this side. That's way too loose. All right, well, I think the overall frame looks good, and you can see we're sized here good for the magnets as well. But yeah, that's way too loose. That's not gonna work. So let me think about that, because we're still gonna need to attach this from the other side. Let me show you what I mean. All right, so it doesn't really matter which is the top or the bottom, although I think that is right because the magnet should be on this side. So this is going to sit in this opening. Now that actually looks pretty good. But we need to still attach it from the other side. Like there's got to be something, either screws coming in from the other side through the coroplast, because I don't want to have screws in the front. So I think we're actually going to need like plates in the back to act as kind of washers, and we'll probably just put some holes in the frame itself. So we might not actually need these. That's the danger in kind of getting ahead of yourself in the design. I actually spent a bunch of time kind of thinking about that and drawing that piece, and the reality is I don't think we need it. Because yeah, we're split here in the middle, but nothing says that our plate on the other side, so the coroplast is going to be here. And then we're going to have a plate or something on the other side that screws into this. There's really no reason why we'd have the split in the same place. That could be multiple pieces. It could run straight across solid there, which will stiffen up that joint and hold it together. So I don't actually even think we need that. And here's another example of that as well. This is an entire box I bought of these bamboo skewers. When I was first designing these side pieces, I was thinking about using these bamboo skewers down the center of them to stiffen it up, and it ended up not being needed. Now, depending on how you use this enclosure, that might be valuable. Let me show you. Yeah, so here is one of our side pieces, and you can see these have a hole down through the center. Now that hole provides strength because we have the extra walls from that, so that actually stiffens up the corner quite a bit even if we don't use the hole. But that hole is sized for these bamboo skewers. It's actually a real nice snug fit in there, which does kind of make, if you're just trying to size something up without actually putting the coroplast in, that can be useful. So I'll put a link to these skewers down in the description as well in case your enclosure, you actually do want those. If you're using the coroplast, I just don't think you need it. I don't think there's really any benefit in having the skewers down through these individual sections. All right, here is the size sheet acrylic that we're going to use. This is not the actual sheet of acrylic that we're going to use. This is just plain old orange tinted acrylic. This is the same thing that the door on the cardboard version of this enclosure used. And if you recall, I said that it was useless. It did nothing. We'll get to that. But for the sake of trying this out, let's just use this because I know this is the size sheet acrylic I want to work with. And yes, there's a reason that there's a piece of it missing. We'll get there. I think that's the trick, is standing it up and forcing the bend into the acrylic. Might have to make these smaller. Wouldn't be surprised if this breaks because we don't have a lot of material to work with there. I think it might have cracked. That's okay though. All right, that's good once it's in place. Now this is going to be flexible. I think what we'll probably have to do is just put like a small bead of silicone maybe around that edge when we put our final piece in, just to make sure that stays in place, but that'll be good enough to test. All right, first thing we need to do is put a dowel pin here in this hole in the top. And that should slip into the hole in the frame. Oh, you know what? Actually, I think I want, yeah, it's okay if that stays there. I'm just trying to think through the order that we have to do this in. I think I actually want this pin in this hole first, because we can't get this pin in from the other side. And then we put our spacer pin in this side, and then our set screw. And if we got all those measurements right, this should, let's just try it. This should push the pin up. Yep. There it goes, pin's coming up. Yep. And if we back this off, it's a little snug in there, so we've got to help it. It's not going to be gravity alone, which could make this tricky getting apart. Although there should be enough of a gap that opens up to just get like a small needle nose pliers and just work that guy back down. Okay, so now, you guys actually see what I'm doing? Now we put that side in, and we line this side up, and we should be able to bring that pin up into the hole in the door. Yeah, it's going. All right, that has bottomed out. Our frame's not staying together here. We just came loose in the top. All right, well, our final one is not going to be able to split there, so it should work. I'll just hold it in place here to get you guys a better view. All right, you guys can mostly see that now. Let's try it. Yeah, that actually swings. Ooh, I like that magnetic closure. That's satisfying. Swings about that far. It's probably not a great camera angle. That's the point at which the door is hitting the frame. So that's pretty good. It swings past the 90-degree mark. It's not 180 degrees. That would be a lot more difficult, I think, to design, and we'd probably have to go beefier on the frame and the hardware just because it would stick out past. But I'm happy with that. Let's see if we can put it up in place in the enclosure and just kind of preview it. Yeah. Yeah, it looks good. I can't even see through it yet, and I already like it. All right, well, I think I'm going to go figure out how to design the retaining portion of this. Again, I think we can just do a series of plates that go all around the outside. And yep, that's exactly what I did. So the white pieces that go all the way around the perimeter here, basically just sandwich that coroplast in the middle. That's what the gap is here. So screws will go into each one of these holes, go through the coroplast, and then into the outer part of the frame for the door. And the holes will pre-exist in that frame. I'll get those added, and we'll reprint the upper and lower portion of the door with those updates and without those weird dovetail parts in there that we just ended up completely not needing. So the way I did these plates, you can see it's one solid piece across that gap, and there'll be 4 screws in each one. That should be plenty strong enough to hold that. And we'll have the coroplast in there as well, also adding rigidity. And the raised sections on here are partly just to kind of keep the bulk, the overall thickness of this down, but still give us some extra rigidity. I'll do 3 walls on these, so that means we'll have 3 walls on these raised sections as well. Should give us an extra bit of strength and kind of keep the heads of those screws countersunk down to the right level as well. And the screws for this will be similar to the ones that we used for the rest of the enclosure. So, all right, I got a bunch more pieces to print. I will bring you back. Okay, while we're waiting for those to print, let's talk about what we're actually going to use for the clear acrylic material for the door panel. Because if you guys recall, when I built this cardboard one, I had this orange tinted panel in here, and I didn't really expect this to be safe, but I figured it would probably diffuse the laser light if it bounced out, and maybe even filter some of it. Turns out that's not true. Let me show you. Okay, I've got a piece of just scrap material here. This is black PLA, and I have focused the laser on the top surface of this material, and I've got framing turned on. That's why we have this little line here. That is just 1 centimeter long. And this framing laser, by the way, does not harm you. It doesn't harm your eyes, doesn't harm your skin. It's just previewing where it is that you're going to do the engraving. And I'm going to engrave this at the same settings, actually a little bit higher power. I'm going to do 25% power. 50, let me check the settings. All right, we're going to do 25% power, 3,600 millimeters per second, 50 kilohertz for the frequency with a pulse width of 80 nanoseconds. That is a little bit more power than I typically use for engraving PLA or PETG, but I want to use more power than I normally do to kind of make a point here. And I mean, we want to make sure that we're going to protect for the power that this laser is actually going to output. So let me first, without anything on this material, just try engraving this with those settings so you can see what it does to this blanket material. And yes, I am wearing my laser safety glasses. All right, that did actually engrave that. You can see it there, but it is such a small line because I'm just engraving the width of an infinitely small line that's basically as thin as the laser can draw with the XY. So let me instead make it a really narrow rectangle, maybe like 0.5 millimeter wide, and have it on fill mode, just so that we can actually see the mark. All right, that's just too darn hard to see. Let's use this side. This textured side is really hard to see. This is a scrap piece I used when I was fine-tuning the settings for the wrench that we did a while back. Let's use this piece. I think on the top flat, shiny surface, it's going to be a lot easier to actually see the mark. All right, now let's do the exact same thing, but with a piece of the orange tinted acrylic that I used for the door in the test version. And yeah, this is cut out of that piece that we used to try the door. So I'm going to set it right down on there. Framing on, and just make sure that we'll do it like kind of right next to that previous line. Now, the result that we want here is we don't want the plastic to get marked. Instead, we want the acrylic to get marked. We want the material that we're using for our protective layer to be sacrificial. We want it to absorb the energy from the laser and not damage our workpiece. That would prove that this material is doing something. And, well, we made a small mark on there, a little bit, but take a look at that. Yeah, the mark on our material looks pretty much exactly the same. So I guess this did maybe do a little bit to diffuse that light. Just because I can see, you know what, I bet you that, I bet you that's just the smoke from the material coming off of here a little bit. Let's try spacing this off the material. I want to find out if this actually is doing anything or if that's just debris from the ink vaporizing in the PLA. Okay, we'll position that right between our two existing lines, and you can see, well, yeah, you can see there I can see it in the camera, where the framing is roughly in the center here. We'll make it like almost right in the center of our acrylic. Yeah, not a mark on the acrylic. Anything you're seeing on there is my fingerprints. It didn't even make the slightest mark on the acrylic, and it engraved our material perfectly. So this is completely transparent to this fiber laser. This does nothing to block it. Me putting this material on as our door on the cardboard enclosure, completely useless. Okay, so clearly there is some difference between this orange tinted acrylic that I bought off of Amazon and these laser safety glasses that, actually I bought these off of Amazon too. But these are at least rated specifically for the wavelength of light that this laser is. It falls between the 800 and 1700 nanometer wavelength. And OD5 describes the amount of reduction of laser energy through these lenses that you can expect. So if we want to be able to use this machine with a window and trust that if someone walks up to the machine not wearing laser safety glasses, that it's going to protect them, what are we going to use? All right, guys, this is a rabbit hole that went pretty deep, pretty wide, pretty quick. I'll give you the short version. What I ultimately discovered is that whatever you buy, you're just trusting the company that you're buying it from, that it is the correct material for the application you're using it for, and that it actually meets the correct safety rating that is, either stamped on it or, that it says on the listing. There's a number of places you can buy this laser safety acrylic material from. I mean, there's a couple listings on Amazon. There's a bunch of listings on AliExpress and like the other, Chinese import sites. The thing is, I kind of like having my eyes working. So, I'm probably not always going to be wearing my laser safety glasses while this machine is in the enclosure with the door shut. And I want to know that my eyeballs are safe and anybody else's eyeballs are safe that happen to walk into my shop while I'm engraving something. So I reached out to these guys and told them what I'm trying to do. I told them I tried some orange acrylic first and got no results from it whatsoever. That it was just completely transparent to the laser, and which honestly was a surprise to me. I didn't expect it to do much, but I expected it to at least defocus the laser a little bit, maybe diffuse the beam nothing. As you guys saw in the test, it did nothing. Whether we had the material right up on what we were trying to engrave or lifted up off of it, it did nothing. Told these guys exactly what I was trying to do. I gave them the wavelength of light for the laser. I told them the wattage of laser that I wanted to be safe from, because even though it's just a 30 watt today, I'd like to ultimately have 100 watt or maybe even more MOPA laser. And this is what they spec. So let's get this open. Okay, so this is definitely more of like an amber color. Let me grab my safety glasses and that acrylic. All right, I don't know how much color really has to do with it, but if we were to compare sort of the shade, this is really orange. This is kind of maybe between this and this. One thing I'm noticing is you could see through this a lot better than this. And that was one of the things that these guys were telling me was the higher quality material passes more light so that you can actually see what you're doing, but still protects you from the laser. And you can see the part number on here. And they have all the ratings. So this guy is, let's see, we are up here, the 940 to 1055. Actually, that's perfect. So I did give them this specific wavelength of light that this laser is, and you can see that we're OD10 plus. So this is actually more protective than these laser safety glasses, even though this is passing more light. And it still has like the protective stuff on it. It's probably going to look even better once I take it off. That's interesting to me. So that's probably, yeah, I wonder if that is maybe one of the big differences in the cheaper pieces of material versus the more expensive pieces of material. We're still going to test it. Let's peel back the edge and let's go do that same test with this material. And I don't want to damage this, or well, I mean, actually we are going to damage this. If we don't damage this, then it's not doing its job. But I don't want to damage it where we're going to see it. So we have that frame. Let me grab that. All right, so if we take a look at our frame, there is probably a good, like, I don't know, maybe 5 or 7 millimeters where the translucent material is blocked by the frame anyway. So what I'm thinking we'll do is we'll try and just do the test here right at the edge where we're not going to see it. All right, here's the test setup I came up with. I used some masking tape just to pull back the protective layers on both sides, and we're lined up at the very edge of the sheet. We're maybe like 3 millimeters in from the edge. And I've got our same piece of material underneath as before. I haven't changed the focus, power settings, anything else. I really don't know what to expect. What I'm hoping happens is that we don't do any damage to the plastic, and that we do, I guess, do some damage to the material, because the laser energy has to go somewhere. So let's hit go. I'm not immediately seeing any damage to the top of this material, which is honestly a little bit concerning. Oh, look at that, nothing. So, oh, I can actually see, trying to get the light on it just the right way that you guys can see. I don't know if it helps having the reflection of the light there or not, but there is actually a mark on the material. It's faint. My guess is it does not take a whole lot of energy to mark this material. So this is probably just dispersing the energy more since it's partly translucent. Unless the mark is on the other side. Nope. Yeah, there's really just a very small mark on the top of this that I don't even know if the camera is picking up. Hopefully you guys can see that. And here, I'll get this close. Nothing on that. Let's up the power. Yeah, let's just go right to worst case scenario. I'm going to set it at 100% power. Okay, well that definitely did something. I can see a very apparent mark on the material, but what do you think underneath? Fingers crossed. Nothing. Nothing. No mark at all. Wow, that is actually a, yeah. So, okay, so we deeply engraved the acrylic. If there's anything on the other side. It's funny, you can't, oh yeah, you can see it from the other side. But no mark on the other side. I don't know if you guys, I kind of aim this the right way. You can see there's no marking on the other side of this material at all. It really, it absorbed all the energy right at the surface of the sheet. All right, well, I'm glad we had that on the edge because you can definitely see that. All right, I can already hear you guys down in the comments. I know you probably want me to try the same test on these glasses. I'm curious as well, but I really don't want to ruin the glasses. There's not a lot of extra surface area on these guys, and presumably the marking that's on here was done with a laser. Yeah, I'll admit, I'm tempted, but I don't want to ruin them. All right, I'm really happy with that result. The fact that this material absorbed 100% of that laser energy, you know, it didn't even make a mark through to the other side of the material. It pretty much all got absorbed right at the face of this material. And that was 100% power. So that was 5 times the amount of power that we tested with on this piece versus this piece. And it still didn't make any mark at all on our black PLA material, which is pretty darn easy to mark. It doesn't take a lot of energy at all to actually mark that. So I'm confident that this is actually going to work. And thanks to the guys over at Laservision for helping me out with this project. Not only did they help me figure out what was the correct material to use for this specific application, but they actually provided this piece for our build. When they heard that I was testing with a piece of plain old acrylic and had no result whatsoever, they were also really interested to see in this specific application how this would function. And I'm sure they knew it was going to do a good job. These guys know their stuff. So if you have a need for laser safety protection, particularly in like a public place, like if it's a makerspace, someplace where you cannot run the risk of laser light damaging someone's eyes and you can't expect everyone to wear safety glasses, definitely reach out to these guys. They will help you. All right, I had some challenges getting these pieces done. This is our test piece from earlier, and if you look closely, the surface finish on parts of this are really not very good. This is done in the Neptune 4 Max, and even though I have the long preheat for the bed on that machine, the bed still moves, it lifts a little bit, leading to this poor surface finish. I eventually adjusted my G-code to have it basically soak the bed for a full hour instead of the 25 minutes that I was doing. And that actually yielded really good results, like much better. It's funny, you know, in the video I did for fixing that machine with the heat soak, people complained about the 25 minutes, and it turns out that's not even long enough. A full hour is really what it takes to get good quality, consistent prints out of that machine for the bed to fully soak. Unfortunately, I removed the supports right when they came off the machine. I should have done that on camera, but I brought them out just to show you how cleanly these came off. If you look, so this is the layer you're seeing here is like the thin layer that's the transition from the supports to our actual 3D printed part. And that pretty much came off in one piece. There's a couple places where it pulled off and a thin piece of material was stuck on this that just came right off. But for the most part, these supports came right off. All right, I think the first thing I want to do is get that nice piece of acrylic material into our frame, because in addition to holding it with these little like sort of pieces here, I think we're going to need to put something in there to firm that up. Maybe like a little bit of silicone caulk just into that corner. Let me think about that. I guess we should probably make sure it fits first. I really don't want to scratch up this material. Oh, you know what? We got to press the magnets into this guy. Let's do that first. All right, I guess we should probably pull the protective cover off of this. I really don't want to scratch it up, but if we're going to put some caulk or some sort of material into the corners, that's going to make pulling this stuff off later really hard. I also want to make sure it actually fits in there. All right, it's in. And yeah, there's where we damaged it in testing it, and that's going to be completely covered by the bezel. Okay, so here's our frame pieces, and I actually did run into some issues with these. I found all 3D printers will close up small holes a little bit tighter than you've drawn them. That is really the case with the Neptune 4 Max. The tool path on this machine, just anything I design that's really small, the holes really seem to close up, much more so than on my Bamboo Lab machines. So when I printed I think this is the bottom. Yeah, this is the bottom because there's our hole for the set screw. This is the top. I adjusted the design before I printed this to make these even bigger, and I also put a little bit of taper into that hole as well. So this one we could probably use as is. This one I think we're going to need to drill these out a little bit. Otherwise, I'm worried that this might actually split. So if we're going to bother setting that up, we'll probably drill these out a tiny bit bigger as well. And I don't want to go through, but we need to come within probably about 2 millimeters of that front face. So I think I'll get a bit set up in the drill press and set up a stop so that when we come down with the quill, it's impossible to go through the front of this. And we'll just drill all these to the exact same size. All right, guys, well, if you looked away from your screen just a second ago, you missed me picking this up and snapping off all these pieces inside the frames. I don't know what is dumber, picking it up like that and snapping all the pieces off, or choosing the most brittle PLA that I own to join these pieces together, because, yeah, they just all snapped off clean with the edges of these. And I tried pliers, I tried side cutters, I even tried drilling these out. It's not going to happen. I'm going to have to reprint these pieces. And these are, I think, 4 or 5 hours a piece on these prints. They don't look like much, but they're big. And that machine is pretty slow, and it's a lot of supports. So I'm going to go kick off one of these prints right now. I think it is, yeah, it's about 11:30 on the East Coast here on Friday. So apologies, we're not going to be able to finish this tonight. Believe me, I'm just as disappointed as you are. I was really excited to see this door on here. But you're not going to have to wait till next Friday. Like I said, I'm going to go kick off one of these prints right now, and I'll start the second one when I get up tomorrow morning. And sometime in the afternoon, I should be able to shoot getting these installed. I'll edit and get the video posted tomorrow in the evening. That'll be Saturday that this is posted. So yeah, guys, again, my most sincere apologies. But hey, I mean, this is real life. I'm one guy in his garage just designing and building stuff. I don't have some magic cart behind me like a TV show that might have had, 5 or 6 of these spare in case something happened. This is just me in my garage. Yeah, so I'm gonna get these reprinted. We'll get this door finished tomorrow, and then in next week's video, so next Friday, we'll design all the other pieces that go along with this. So the fume extraction inlet or outlet, I guess. We're going to need something for the front of this so that I can access the buttons on the front of that machine, and we're going to need something on the back as well to be able to get the USB and the power in. I've already started designing all those, so I'm pretty confident that next Friday will be the complete finale of this project, including all of the pieces we need to make the full enclosure. And yeah, I feel cheesy saying it, but if you're not subscribed to the channel, I guess now's a good time to do it so you don't miss tomorrow's video. Night, guys.